Hello, hello, hello. Adina, can you hear me?
Yes, sir.
Yes, sir.
Okay, can I share the screen? Okay, I will share the screen. Here we were discussing this one. Now we will wait for participants. We will check the participants. Only 5 participants are there. Add the participants. 7. Where are the remaining? Eight only. What about the remaining students? अरे ओरडू नका. Only 9 participants. Send the message to join others. Ten. Be fast. Send message to others. Only 12 participants. Adinath.
Yes, sir.
Hello. Ask others to join.
The message केलाय group.
हाँ.
Hi.
16. Okay. I will take the revision of yesterday's lecture. Then we will start the shear stress. Okay. Shall I start now? Shall I start?
Yes, sir.
Here we were discussing this one, elements subjected to biaxial direct stresses. Here we have to calculate the normal stress, shear stress on plane making an angle theta. That is on this plane BE. Now we have to find the location of the principal stresses, and we have to find the shear stress on this plane. Now what is the location of plane carrying maximum shear stress? That we are starting. Now we have completed this normal stress. Now see here how we have completed normal stress. Now this element is having thickness 1 millimeter. So force on AB as stress is sigma x. Force on AB is sigma x AB. Force on EA it is sigma x AE. Sorry, sigma y AE, not sigma x. It is sigma y. Okay, sigma y AE. Here it is showing the free body diagram or forces acting on this AE and AB. Now these forces, when we apply or when we extend line of action of these forces on EB, these forces are not normal to this EB, not tangent to this EB. So we have resolved these two forces in two components. One component is normal to EB and one component is tangent to EB. Now you see this one here. This is the normal component sigma x AB cos theta. It is the normal component because of the sigma x AB. Now here this angle is, therefore this angle is also theta, and normal component becomes sigma x AB. Okay. Next one, this is the normal component because of the sigma y. Sigma y A sin theta because of this sigma y A. I think I have covered this one. Now resultant normal force on B, it is summation of this force and this AB. Okay. Now this is the normal force Pn. It is equal to the sigma x AB cos theta plus sigma y A sin theta. Have you got it? Next one. Yes. I am assuming. Is it visible? Is it visible? Uh,
Yes, sir. Yes, sir. Yes, sir.
okay. Now sigma theta be the normal stress on plane B. That means we have assumed the sigma theta as the normal stress on plane B. That means here normal stress on this plane B is sigma theta. Now if this is a normal stress, then what is the normal force, normal resultant force on this B? That is sigma theta into area of the B. As thickness is unit millimeter, then force on this B, it is sigma theta into B, just the length of this B. Okay. Now therefore, when we equate this equation and this equation, we'll get sigma theta B equal to the sigma x AB cos theta, sigma y A sin theta. Now for calculation, our aim is to calculate the sigma theta. Am I right? Now for calculation of this sigma theta, what I have done, I have divided by B to whole equation. Now when we take B on this side, it becomes sigma x AB by B cos theta plus sigma y A by B sin theta. Now AB by B in this figure, you see this figure, AB by B, it is a cos theta, and AE by B, it is sin theta. Therefore, here you put AB by B equal to cos theta. Now sigma x into cos theta, it becomes sigma x cos square theta. Next one, sigma y A by B is sin theta, sigma y A by B sin theta into sin theta. Now it becomes sigma y sin square theta. Now see here. Now at the start of this unit, we have derived one equation, that is a normal stress on inclined plane because of the single force sigma x. Now see here, if we make this sigma y 0, your equation for the normal stress on the plane making an angle theta is sigma theta is equal to sigma x cos square theta. Am I right? Is it same to the equation which we have derived at the start of this? That is the normal stress on making an angle theta. Okay. This equation we have derived. Now in addition to that, there is a sigma y. Now cos square theta I will replace by 1 plus cos 2 theta by 2. Okay, this is a standard relation from the trigonometry. And sin square theta I am going to replace by 1 minus cos 2 theta by 2. It is also standard relation from the trigonometry. Therefore, your equation becomes sigma theta is equal to sigma x into 1 plus cos 2 theta by 2 plus sigma y into 1 minus cos 2 theta by 2. Next I will add the terms having cos 2 theta and the terms which don't have cos 2 theta. That is, first term is sigma x by 2. Now next is sigma x cos 2 theta by 2. I will take separate out. Here sigma y by 2. Therefore, sigma x by 2 and sigma y by 2. This term becomes sigma x plus sigma y by 2. Remaining term is sigma x cos 2 theta, sigma y cos 2 theta. That is sigma x minus sigma y by 2 into cos 2 theta. This is the equation for normal stress on inclined plane. You have to remember this equation when problem is asked to calculate the normal stress on inclined plane. Then you have to use this one. Okay. Now see here. Now after that, what we have discussed? We have discussed this one. See here, this is equation. Now when 2 theta is equal to it is where it is this one. When 2 theta is equal to 0 or theta is equal to 0, then sigma theta is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2. Now sigma x y by 2 and this sigma y by 2, cos 2 theta in this case is 1 na? Okay, when theta is equal to 0. Now sigma y by 2 and sigma y by 2, this is a plus and this is a minus, they will cancel with each other. Therefore you will get sigma x by 2 and sigma x by 2, that is equal to the sigma x, and this is the maximum stress on the plane AB or on the body when body is subjected to two mutually perpendicular normal stresses. Okay, now see here, therefore the plane which is making an angle theta is equal to 0, that is the plane carries maximum normal stress. That means this sigma x is the maximum normal stress, that is the yes, major principal stress, and theta is equal to 0 is the position of major principal plane, that is plane carrying maximum normal stress or plane carrying maximum or major principal stress. Okay, have you got the position of principal plane? Reply me, have you got the position of principal plane?
Yes, sir.
Okay, now this is a major principal plane position and this is the magnitude of the major principal stress. Now for minor, when 2 theta is equal to 180 or theta is equal to 90, theta is equal to 90. Now how this equation becomes? This equation becomes sigma x plus sigma y divided by 2. Cos 2 theta is cos 180 and it is a minus 1. Therefore this sign will be changed and it becomes negative. Therefore when this sign is negative, this value will be minimum. This value will be minimum because of this 180 degree or because of negative sign. Now what is the minimum value? Minimum value is sigma x by 2 plus sigma y by 2 minus sigma x by 2 minus sigma y by 2. Now this sigma x by 2 becomes negative and sigma y becomes positive. Sigma x by 2 and sigma x by 2 will be cancelled with each other, and sigma y by 2 plus sigma y by 2, it becomes sigma y. This is your minor principal stress. This is your minor principal stress, or this is the minimum normal stress acting on the body. And here for this type of loading only, that means for this type of loading only, it is not for other type of loading. Okay, minimum normal stress is sigma y and maximum normal stress is sigma x, and position of minimum normal stress is theta is equal to 90 degree, that is it is at 90 degree. Now one more observation I have missed. Now what is angle between major principal stress and minor principal stress plane? That is plane carrying major principal stress and plane carrying minor principal stress, or major principal plane and minor principal plane. Now see here, this is at 0 and this is at 90 degree. That means angle between these two planes is 90 degree. Now what we can say, see here, when body is subjected to biaxial stress system, there are two mutually perpendicular planes. One carries maximum normal stress, one carries minimum normal stress. That maximum normal stress is your principal stress and minimum normal stress is your minor principal stress. Okay, one is major principal stress and one is minor principal stress, and these two planes are principal planes. Okay, now you got the position of the principal planes and you got the magnitude of the principal stresses. Also you got the normal stress on inclined plane. Now see here in our question, normal stress, you have completed this normal stress. Okay, now you have completed this, what is the location of principal stresses. Okay, now we have to calculate the shear stress on plane making an angle theta, and what is the shear stress on principal planes, and what is the location of plane carrying maximum shear stress, that we will discuss today. Now shear stress again you see this one, this body. Now in normal stresses we have resolved the forces, we have considered the normal component of the force. Now this force here, What is this force here? This is sigma x, and this is sigma x AB. Am I right? It is, I will write here, sigma x AB. Okay, this is a force when we extend this force on EB. Now this plane is EB here. This is your E, and this one is B. Okay. I have extended the line of action of the force sigma x AB on plane EB. Have you got up to here? Now we have taken normal component for normal stresses. Now here we have to take the shear component or tangent component. Now tangent component is like this. You can see it. Tangent component like this. It's perpendicular to okay. Now I will increase the size of this. Now this is a tangent component. Okay, we have resolved that. Na? This here, this we have taken as a normal component. Am I right? Now this we have to take the shear component. I will delete this normal component. Now it is making an angle theta with the vertical. It is making an angle theta with the vertical. Okay. Now theta this angle is theta. Have you got it? Just a minute. Hello, hello, hello. One has. अरे recording कुछ चालू करे. Hello.
Prathamesh.
Prathamesh. Now, can you hear me? Reply me.
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now, what
Yes, sir.
this sigma x AB is the force on EB which we have taken from this force. Am I right? This I have extended just this force here. Okay. Now I want to find the tangent component of this one. Now here angle made by this plane with the vertical is your theta angle. Okay, sorry. It is your theta angle. Okay. Now I want to calculate this component. Now when I extend this, you see here, when I draw this line, and one more thing, this is a 90 minus theta. Is it correct? This angle is 90 minus theta. Already we have seen. Now when I draw the perpendicular from here, and when I extend this one, you see here, this angle is 90 degree. This angle is 90 degree. Here it is 90 degree. And this angle, it is, I will show you, theta. I will show you theta. Where is theta? This angle is theta. Am I right? Do you agree with this angle is theta? Can you have any problem for this theta? You see this. This line is perpendicular to this plane B. Am I right? Okay. Now we have to calculate this component. Now what is this component? Can anyone tell? This component, tangent component. Now this tangent component is sigma x AB
AB sin
sin theta na, sin theta. Okay, this component is sigma x AB sin theta. This is because of the sigma x AB. This is because of the sigma x AB. This is your sigma x AB. Okay, this is sigma x AB and this one is a sigma x AB sin theta. Now first tangential force is because of the sigma x and it is sigma x AB sin theta. Now second tangential force, for second tangential force, what I will do, I will take this plane again. Now you have vertical component, and what is magnitude of that vertical component? What is magnitude of that vertical component?
Sigma y.
It is sigma y AE, na? Sigma y AE. This one is, I will here sigma y AE. Have you got this? Now we need to find the tangent component of this one. We need to find tangent component of this one. Now here it has angle theta. It has angle theta. Okay. Now how we can find the tangent component? Tangent component is here. See here. This is your normal component. Okay. And tangent component is this one. Okay. Tangent component. Now here I will write the what is magnitude of it is making an angle theta with the vertical. Theta with vertical. Here this angle is theta. This angle is theta means this angle is also theta. Okay. Now when we draw the normal line here, okay, this is 90 degree. This is the your sigma y AE, sigma y AE. Okay. Now this angle is theta. Now what is this magnitude? What is this magnitude? This one. What is
sigma y AB
sigma y AE?
cos theta.
Cos theta, na?
Cos theta.
Cos theta. Yes. Sigma y AE. I will write here. It is sigma y AE cos theta. Sigma y AE cos theta. Have you got it? Sigma y AE cos theta.
Raman Rukmini.
Avinash.
Or sigma y AE cos theta. Next one, what is the total tangential force on B? Total tangential force on B. Now it is the addition of this force and this force. Now total tangential force on B, it is, you can see here, this is sigma y AE cos theta, sigma x AB sin theta. Have you got it? Now total tangential force is addition of these two. I have combined these two things. You see this one. I have combined these two things here. Here this is sigma x AB sin theta, sigma y AE cos theta. Now here this is your sigma y AE cos theta, sigma x AB sin theta. Now total shear load or tangential force on plane B is, suppose it is PT because tangential force, it is sigma x AB sin theta. It is acting in downward direction. I am taking this downward direction as a positive force because we are going to calculate only resultant. Now I will consider this as a positive and this is in opposite direction. This I will consider as a negative. I want to calculate magnitude only. Okay. Now here you got this sigma x AB sin theta minus sigma y AE cos theta. Okay. This is the total tangential force on plane B. On plane B. Okay. Next one, that is on plane making an angle theta. Next one, if same to last case, tau is the or tau theta, we can say tau theta is the shear stress on plane B. Okay, now what is a shear force? Shear force on B. Okay, it is equal to the shear stress into area of B. Am I right? Have you got it? Now what is shear stress here? Tau theta. Tau theta is the shear stress. It is tau theta is the shear stress. Okay, and what is area of B? Area of B, yesterday also we have taken area of B. It is just B, na? It is just B, and this is the shear load or shear force on plane B, and it is equal to the P T we have assumed here. Okay, now I will equate this equation and this equation. Okay, tau theta B equal to the shear force. Now here I have written this equation. You can see this. I will copy this here. Tau theta B equal to the sigma x AB sin theta minus sigma y A cos theta. Have you got up here? Reply me.
Yes, sir.
Now what I will do, same thing I will repeat. I will divide by BE to this equation. Now I will copy here and I will divide by BE to this equation. Now this will be AB by B, and this will be AE by B. Okay, over. Now again go back to this one, these two equations. I will copy here. You see these two equations. AB by BE is equal to cos theta and AE by B equal to sin theta. Now how this equation will be? This equation will be modified here or changed here. Sigma x okay, I will write here sigma x cos theta sin theta. Next sigma y, and this I am going to replace by sin theta. Have you got this? It is, you see again, sigma x AB by B is replaced by cos theta, therefore it becomes sigma x cos theta sin theta. Sigma y AE by B, it is a sin theta, therefore it becomes sigma y sin theta cos theta. Okay, Adinath, have you got it?
Yes, sir.
Okay, next one, what I am going to do, I am going to replace this this equation you see here. Same equation I have written here, cos theta sin theta. I am going to take common from this, that is sigma x minus sigma y cos theta sin theta. Now how this equation becomes? Here, okay, I will write in front of this equal to sigma x Now this plus sigma y and it is in bracket. Okay, I have taken the common sin cos theta sin theta. Just now this equation will be like this. Have you got it? Just I have taken sin theta cos theta common from these two terms. Sorry, here it is minus, na? Minus. Okay. Over. Now product of cos theta sin theta, it is the sin 2 theta by 2. Sin 2 theta by 2. Therefore, your equation will be like this. That is, this is tau theta. Okay. This equation becomes tau theta is equal to sigma x minus sigma y by 2 sin 2 theta. This I have replaced by sin 2 theta by 2. Have you got it? Have you got it? Reply me. It is very important.
Yes, sir.
Yes, sir.
Okay. There is no any question. Okay. Now we will see the observations related to this one. Now see here. This is equation I have already derived. Sigma x minus sigma y by 2 sin 2 theta. Now see here, shear stress is maximum on two planes. Which are that two planes? One is when 2 theta is equal to 90 degree. When 2 theta is equal to 90 degree, means theta is equal to 45 degree. Okay, theta is equal to 45 degree or theta is equal to 135 degree. Now you see here, theta is equal to 45 or theta is equal to 135. Okay. Now these two planes are perpendicular to each other. Am I right? Am I right? Now I will go back. Here I will take this one here, and in question I will go. I will see here. Shear stress is maximum on two planes when 2 theta is equal to 90 degree. 2 theta is equal to 90 degree and theta is equal to 45 degree. That means when this value of theta is 45 degree, then your shear stress is maximum. Okay. Or when theta is equal to 135, then also this value is maximum. That means maximum shear stress you will get on a planes making an angle 45 degree or 135 degree. Have you got the position of the plane carrying maximum shear stress? Have you got this? Any doubt here? Have you got this?
Yes, sir.
Okay. Now you see here. This is the position of plane carrying maximum shear stress. Now here this is the equation for the shear stress at an angle theta. Means have you got the shear stress on a plane making an angle theta? This one. Okay. Or this is a shear stress equation, which is the value of the shear stress on plane making an angle theta. Now see here. What is the principal plane here? Principal plane is the AB. Am I right? AB and AD. Is correct? AB and AD. These are the two principal planes. Now, what is the shear stress on these planes? Now see here. For AB, theta is equal to 0. Do you agree with this? Theta is equal to 0. Now, when theta is equal to 0, what is the shear stress? Shear stress is also 0. That means shear stress on principal plane when theta is equal to 0 and theta is equal to 90, it is 0. Okay. Have you got this? This is the third question. Shear stress on a principal planes. Have you got this? Okay. Now we have derived all these things. Now shear stress on plane making an angle theta. Next, shear stress on a principal planes, it is 0. You have to remember this. Always it is 0 on a principal planes. and it is in definition also. This definition of the principal stress also. Shear stress on principal planes is 0. Now plane carrying maximum shear stress. Plane carrying maximum shear stress, it is at 45 degree with the principal planes. Okay, have you got this? It is here, it is at 45 degree with the principal planes. See here, therefore you have to remember this is also standard rule for all cases. Angle between the principal planes and plane carrying maximum shear stress is 45 degree, and shear stresses on principal planes is 0. Now what is the magnitude of the maximum shear stress? What is magnitude of the maximum shear stress? Can anyone tell? It is magnitude of maximum shear stress. Yes, tell me. Magnitude of maximum shear stress from this equation. Are you listening me?
Sigma x minus sigma y by 2.
Sigma x minus into 1. That is sigma x minus sigma y by 2. Okay. Have you got it? It is the maximum shear stress. Already I have derived here. You see here. Maximum shear stress is sigma x minus sigma y by 2 because sin 2 theta is equal to 1 for that angle. Am I right? Now one thing I want to tell you here, if you observe this equation, shear stress equation, now, and if you compare this equation with the first case, in first case when there is only one normal stress, that is sigma y is 0. When sigma y is 0, shear stress on inclined plane is sigma x by 2 only. That means this equation you can use for that also. That is, this derivation you can use for first case also, where sigma y is 0. Sigma x by 2 into sin 2 theta. That is the shear stress on plane making an angle theta when body is subject to only one normal stress. Am I right? Okay. And you can see this.
I sigma y is to 0.
Here I am not taking 0. I am going to compare this with the first case. First case means first case is yours. Here, this one. This case. Here only one normal stress is there, na? And that equation is sigma by 2 into cos sin 2 theta. Am I right? When sigma y is 0. Here in this case sigma y is 0. Is it correct?
Okay.
I am going to show you this equation also we can derive by this method. This by considering this case when sigma y, when we put sigma y equal to 0. Okay, and you see the maximum shear stress. Maximum shear stress in this case, maximum shear stress is sigma by 2. Am I right? Sigma by 2. Now here maximum shear stress is sigma x minus sigma y by 2. Now when we put sigma y is equal to 0, you will get the derivation similar to the first case. Okay. Now have you got up to here?
Yes, sir.
Okay. Now resultant stress on the plane making an angle theta. It is just sigma theta square plus tau theta square. Resultant stress on a plane making an angle theta. Now one more definition I want to tell you here. It is a obliquity phi. It is the angle made by resultant with the normal stress. That means I will show you here. Here this is a plane. This is a plane, and it is a plane at an angle theta. Okay. Now normal stress, resultant normal stress on this plane is like this. Resultant normal stress is like this. That is, here I will use this color. Okay. Next one, shear stress. Shear stress is like this. Shear stress on this plane is like this. You see this. I will change this color. Okay, I will take this one. Okay. Now this is a normal stress. This is a shear stress. Your resultant, according to this equation, it will be here, na, in between these two. Is it correct? It may be like this resultant. Okay, it is same to the resultant force.